So let's get started. Someone need to come in. Yes. So I hope you have good holiday yesterday. It is National Day. So the goal of today would be oh, where's my slide? My slide is here. Just wait a bit. Is to finish this equilibrium idea, and then we can go to uncertainty. And last class, we work on partial equilibrium. And this class will be related to general equilibrium. And those of you who work on macroeconomics, work on finance, this will be the topic that will be interest. Or if you care about supply chain, that will also be the case. The reason of talking about partial equilibrium is because of we can't do analyze everything at the same time. So we must left something unsolved, something exogenous, right? Because you build a model, you can't have everything endogenous, right? If you do it, that will be, the model will be too complicated to solve, right? So you want to solve more stuff, right? Of course, it comes at a cost, it's more complex, right? Probably you can't get everything out, but today we're able to take on this complicated issue. And it turns out later you will see even for existence of equilibrium is a big issue, right? So that's why you will see very early literature, at least in general equilibrium, focus on proving the existence, okay? And whether equilibrium exists is the first issue. And second issue turned out to be because of you solving equilibrium different market, and it is not likely to have a one equilibrium, right? Even if you didn't solve it, later you will see in the partial equilibrium model, we've seen Carnot-Bertrand has a very nice one equilibrium, okay? And very soon when we learn game theory, and there will be more than one equilibrium, okay? But here, even in this case, general equilibrium, you will see potentially there can be numerous equilibrium. And of course, in the model we study, we will focus on there will be a unique equilibrium, or the reason why you are unique is because of you make some assumption, right? But if you don't make those research assumption, likely that you have more than one. Okay. Even if you make assumption, individual have nice, well-behaved downward sloping demand and supply curve is tight there, then you don't have a unique equilibrium. Okay. But the problem is in that case, what might be the result? Right? And probably that actually explains why in macro, right? Why you have recession, why you have boom, right? Because if equilibrium does one, why we have seen inflation, why I've seen so many things there, right? There must be some reason that things happen, right? I mean, the economy doesn't change that much, right? Because there's a fundamental question, actually, everyone study finance, right? It's like the macroeconomy is not moving a lot, but the financial market moves a lot, right? Of course, there's a big thing about a monetary economics to study why the financial market move so much compared to the macroeconomy, right? And actually, there's also another way to study in the financial economics. It's like why the financial market is looking at driving the macro, right? Because when you see recent economic crises are driven for financial crisis, right? So look at 2008 and recent many cases, right? Early the dot-com bubble and other thing is like financial market is very small, but it's driving the whole economy, right? At least from the perspective of the financial boom and the recession, okay? But anyway, we don't want to go too fast, so let's get started. But before we do that, let's have very short review what we have done, because I guess that is very important, right? And the partial equilibrium model is like, we know how things work in perfect competition, right? At the end of the day, it's like everyone a price taker, and everything marginal cost equal to marginal benefit, right? And everything, if you allow free entry, right? Price equal to the average cost, right? No one makes any profit, right? So the market very nicely, right? As long as the market is competitive, right? We know that is the case, right? Everyone's very happy, right? With the Pinduoduo, Taobao, Meituan, right? Because its price is almost drive to average, long average cost is almost zero profit, right? But of course, you know, right? In some cases, not, right? There's some monopoly over there, right? And if you notice, right, right, in Hong Kong, right, if you look at the cell phone cost, not cell phone cost, cell phone mobile service, right, the telecom service is very cheap compared to many places in the world, right? And even in China, it's even cheaper in China, right? And of course, the reason is basically perfect competition, right? Because although there's a few firms, but they are more or less price taker. It's very, very cheap. I mean, you look at many places in the world, Hong Kong, telecommunication cost is very cheap because they're huge competition, right? But in China, you likely have a monopoly, duopoly, right, or triopoly, right? It's several firms, and that's why it's so expensive, right? But it's not the case in the old days in Hong Kong. It's like they're only one firm, and they charge so much. It's like crazy amount of money before they open up the market. So monopoly is there, right? And that happened in many places in the world. Basically, just like a single firm is controlling the whole market. But when they open up the market, then everything become way more competitive, right? And then in the middle of the two, right? And you have to take into the equilibrium concept, right? Because the first two, right? The first one is like everyone is making decision based on the price in the market, right? And monopoly is just like he facing the market, he just pick up the point, right? So there's no interaction between firms, right? And when we have imperfect competition, there's interaction, right? Because remember Carnot, right? When we look at the model, maybe just go to the model because I think monopoly and perfect competition is nowhere well, right? Because it's not something that we have to worry. But the Carnot model, right? It's like how much you produce that maximize your profit, right? Really depends on other firms, right? So it's what is optimal, what's equilibrium, you have to define, right? You have to know what's equilibrium because how much I produce depends on how much you guys are producing. So what is my optimal choice depend on your choice, right? And you're doing optimally, right? So that's why the natural one that come from Carnot and Nash is saying that if everyone is producing this much and no one want to deviate from that unilaterally, then this equilibrium outcome, right? And of course, this is some of you may say this is very strong, but indeed this is very weak, right? In some sense, because if you only need to check only one firm deviate, right? You forget about collusion, right? Because you don't allow both firms joining deviate, right? And you don't allow all firms deviate, right? Because you form some collusion of the whole industry, which often happen if you look at antitrust regulation. I mean, there's a lot of cases where you collude competitor to raise the price together, right? And that's what happened, right? I mean, in some sense, right? That's why in business school, right? Ph.D. student, you only have very few classmates, right? Why? Because all of us jointly reduce the output of PhD students, so everyone get a good job, right? But that's not happening in China, right? All schools in China are producing so much PhDs, okay? Then no one have any surplus, right? No one have any rent. Everyone got zero profit, right? But now it's not going to be like this, right? If you look at recent data, right? Look at how many people they produce undergrad, right? It's like 10,000 in school, per school, more or less like that. And how much you get for the graduate? 2 times, 3 times, even 10 times, right? So what happened at the end? No one get anything, right? So I think there's someone said, right? If, as I said, going the statement, right? If you work hard, you increase your marks, right? What happens if everyone work hard? You increase the cutoff point, right? 你个人努力就增加你的分数，大家努力就增加分数线, right? That's what happened, right? So it's actually like this, right? It's just like the Carnot, right? It's just like everyone going to be producing a lot, right? But they would collude, right? In some sense, right? And of course, the question is why you want to ask why the thing in China is like every school is producing a lot of PhD, right? Because of free entry, right? Now everyone can produce, then there's no restriction. And there's no don't collude, then actually turn up into Berchan. That's what happened, right? And you may ask, why the market suddenly from Carnot to Bertrand, right? Of course, that's a research question. You can work on a group project. Why in your research project, why the higher education in China suddenly from Carnot competition become Bertrand, they produce a lot? Is there some reason behind? I mean, they just when they enter, they just lower the price the lowest, right? Why is the case? You have to think why. I mean, before they didn't, but now they have to compete in this way, right? Because everyone lower the price, right, and just grab the whole market. Okay. And it was not like this before, right? So there's must be some reason that goes on behind that. But just to remind you that for Bertrand, right, and even undercut, right, and although the outcome, right, the price is a unit. I mean, we just show you that, argue that last time, right? The equilibrium is not unique, right? Because if in experiment where all the firm homogeneous, right? Equilibrium outcome, the price equal to marginal cost. But there are many equilibrium outcome there, right? Because as long as two firms are charging the marginal cost, or three or more, right? Multiple firms, and some other firm charging any price is okay. Because everyone is making super anyway. Right? So can be the case two firms charge marginal cost, the other charge whatever price, doesn't really matter. Right? So as long as the price is above marginal cost. But anyway, although there's a many equilibrium or many equilibria, the outcome you will observe is you will see the marginal cost pricing. Right? And of course, as I mentioned in the last class, this result is very clean, very simple. Actually, it's a big puzzle for game theorists because no one would believe except very competitive market will see this, right? Because in this model, look at this, it doesn't really matter how many firms you have, right? You imagine you have two firms, you have Bertrand, but unlikely that you see this kind of outcome, right? Unless they're doing price roll, you're doing something like the crazy thing you see in the Meituan and Pinduoduo and Jingdong in the food delivery, right? Basically, get a lot of subsidy, right? Even below, actually the price even below marginal cost, right? In that case, but you can't really use this one shot idea to understand this because it's a multi-period competition. So you have to use a dynamic game idea. We will talk about like 3 weeks or 4 weeks, 3 weeks later, right? It's not just single one shot competition, but it's a multi-stage. Then you can talk about this. Okay. So at the end, talk about this monopolistic competition. That will be something that you would actually do a lot when you do empirical study, because you really don't want to easily model Carnot and Bertrand, but monopolistic competition is an easy way to take the data, right? Because this thing can be easily measured, right? And then that's why in the empirical literature, actually in economics, in trade, in IO, people use this or this variant of type of model because right? Because marginal reference cost and this thing are being equate is much more easier, right? Because it's very hard to do empirically say, oh, okay, my model is going to depend on how firm compete, then probably they would not fly very far, right? But if you really do marketing, you really seriously doing some structural IO, then you have to use Carnot, Bertrand, those kind of ideas, but not this one. But if you're not trying to take this competition seriously, this thing would be working because everyone is doing that. Okay, together with CES production, then there was something that I actually been doing this these days. Okay, I hope I give you the idea behind, but you will, when you read those papers, you will see this thing comes out a lot. Because one good thing about this is model is you have number of firm endogenized, right? Because when you have Bertrand or Carnot, you actually cannot solve the number of firm idea, right? Because it's very hard. Right? I mean, this one is very simple and very elegant, right? It's a smaller, very slightest deviation from perfect competition, right? And everything works very well. So if you want to do empirics, I recommend you to go along this line, okay? And as our class is very introductory class, so I can't go to every single thing in very great detail, but just to point out where you can go further. right? I think that's very important because these days everyone can use AI very quickly. But what I need to teach in the class is to give you an idea what you can go, because you have to start with some prompt, right? Use AI, right? So then I give you some idea, you can go to the prompt and then you can start working. Otherwise, AI can't help you that easily. So let's now go into serious business today. Hopefully in this 2 hour or half, we can give you some idea, some taste of that equilibrium. And in a general equilibrium, we will first establish existence. That's very important. You will see this large literature for the past 40 to 50 years, they focus on existence. Actually, my advisor, basically he spent his whole life in doing this existence in different version. Later you will see why this is important, because in this model, we are only a private good, but in the real world, we are public good. With a locational thing like the real estate, if you do real estate, you will know, I mean, the problem of big chain, if you do finance, you know, there's firms, right? There's a joint ownership, right? But here we focus on result production, okay? You can easily see many results will hold when you extend this to perfect competition, right? But what happened with oligopoly, when the market power, then is it going to exist equilibrium, right? And why you think this is important is because of in the old days, this is a big fight between socialist system and capitalist system, right? And whether the market is good at allocating the resources is a big thing. It's a big thing survival for the Western civilization, right? Because they think about the Soviet Union and the US, they figured out what's a good way to allocate things, right? It's the market that so many people is disorganized, right? Because everyone has their own market. We have equilibrium. And that same goes for the financial market, right? Because there's so many different markets. And the problem of the financial market is even more serious is market is incomplete, right? And it's not everything you can buy or sell in the market, right? So that's how this thing being solved is a big issue. I mean, still is a big issue now. But anyway, we focus on very basic thing, look at existence with simple model, and look at efficiency, right? Because it's market may exist equilibrium, then no one is going to move, the price is there, price is stable, right? There's no financial crisis going on, right? In this simple world. And how market is working. Is it going to be efficient, right? It's better than someone who is able to allocate the thing. Is it going to be there? Okay. Of course, there's one of the biggest thing in this literature we didn't have time to touch on, is if you don't use the market, how will you allocate? Maybe a benevolent social planner, right? There's some guy who is so smart can do everything, right? And turn out I don't have time to talk about is the information requirement for doing so is so huge that actually no one can able to do it. Okay, maybe now with AI probably there's someone who can do it, but before this moment appear, market is still the one of the best way, right? But maybe there one day we will see new thing will comes out because of competition power, may be able to solve this problem because we have a smart contract, with blockchain. There's some way that we remain anonymous, but we're still able to commit, solve the full information problem, and everything become still the privacy is being observed. But that is slightly beyond what we say. But if you want to look at the future, this is something you should go because you want to solve general equilibrium model, right? Because it's a complex system there, right? Because you can imagine this they are working on is like look at the low altitude economy, right? There's many drones can fly in the sky, right? You are not solving the equilibrium within a small geographical region, right? It's like when you put a plane from one area to another area, right? It disrupts the equilibrium in this system, right? Because maybe there's number of flight you can fly in this region. You allow this to fly to other region, there can be everything interrupt, right? So you have solved equilibrium in different geographical location. So that is a problem there. And the next thing we talk about, very last thing is about core. There's a very important concept in what we call cooperative game theory. And game theory, probably you know from this class in the second half of this course, will be non-cooperative game theory. Okay, it's about everyone making decision on their own. Okay? But that is actually not the earliest form of game theory. And the very earliest one is called the called optic game theory, 合作博弈. That is focused on the core. We don't talk about how people arrive this situation. We focus on what situation is stable, okay? And we don't actually look at how things that arrive, but rather look at, is this equilibrium going to stable, have a nice property, and we like it. So you can imagine if you look at econometrics idea, corporate game theory is a reduced form analysis. We don't care about how the inner workings, a macro idea, macro approach, right? And non-corporate game theory is a micro approach, right? Look at how people work, how people think, right? And that is the micro level, okay? And of course, there's a way that we connect these two together, like the micro foundation and macro, right? Try to see whether there's a foundation for the core and so on and so forth, but we focus on this, okay? And if you look at the classical textbook in the microeconomic theory, Marx, Coleridge, Green, you will see he spent 4 or 5 chapters going on to different ways to characterize the equilibrium in, say, core, nucleus, bargaining set, and all kind of thing. And that's very important if you are from the finance background, because there are many ways to, because core is very big, so you want to really shrink it, okay? Because a lot of things can be core. And later you will see that we'll learn what we call the fundamental theorem of welfare economics. It's saying that competitive equilibrium is in the core. Okay? Core is a concept where everyone in this outcome, no one wants to get away. And it's more general than Nash, is because Nash only allow one guy get out of the system. Core allow that not just one, but any subset of agent can get out, right? Not just one group, say 2 people can get out system. Are they happy, right? Or 3 people can get out, okay? So everyone can break away from the system free, okay? So it's a, you say it's a more general concept than Nash, right? So later you will see how we do it, okay? So this is the content of the 2.5 hours. So bear with me, I'm sorry for a lot of notation because this is notation heavy course, so I try to reduce notation, but it's not that easy. But you look at the textbook, you agree that I already simplify a lot, okay? So that is with I consumers, okay? And unfortunately, because we have N different good and I different consumer, so you have a superscript and subscript. So consumer I, consumer good K will be XI K, right? K will be the Kth good, and I will be the Ith consumer. So I'm sorry for notation, but that has to be like this. And both on I will be the consumption on I and different good. Okay? So that you mean that actually there will be, the consumption will be a matrix, right? You'll be indexed by consumer, and each consumer will have I consumer there, but each consumer can consume on N different good. So it's N by K or K by N matrix. So it's a complex thing rather than a vector, right? So we're a matrix there. So that makes the model very complicated, right? You can see. Even without production, okay? So again, we start with every consumer preference represented by utility function, okay? Remind yourself that how you can have this utility function. You at least have 2 things, at least in my class, we talk about you need to have continuity as first, and second, monotonicity. Okay? Of course, monotonicity is not a big thing because, well, probably we just said good K, right? It's good. So already monotonicity is assumed, right? Because good is monotone, more the better. And what we need here is just continuity, right? As long as you assume the preference continuous. Just to remind you what's continuous. Continuous means that if consumer prefer A over B, stroke preference, right? A is much better than B, right? You always prefer A over B when you see that. Means that if you slightly move a little bit from A and slightly move to B, you still prefer that wiggling around A over B, right? So your preference doesn't change suddenly, right? Just to remind you, the lexicographic preference is not continuous, right? The leading example is like in the marriage market, right? You always want a guy 180, right? So if 179, no matter how rich it is, it's not going to valid. Then it's a change a little bit height, will change everything, right? So that is the idea. Now, as we said, we don't focus on production. So that means that everyone will have to start with some goods in the beginning. So it's an endowment. Okay, the endowment can come from somewhere. We don't model it. You can imagine, right? Or you can imagine that everyone have a tree in the backyard. So there's some apple fall down from the tree, or banana he can pick from somewhere. Okay, it's not going to consider the working, but you actually see that as long as there's a perfect competitive firm, profit maximizing firm there, price taking firm, everything holds there. Okay, and of course you ask what happened when oligopoly, those kind of stuff. That is beyond the scope of what we discussed, but that's as long as perfect competition, everything goes very well. So we focus on what we call exchange economy. The economy, just like everyone have some goods, and then they just trade, and we won't look at the price. Okay, so that is the idea. We don't have production. Okay, we just assume production has been done efficiently. There's some way to do it, but we just skip that part. There's no production there. Okay, so the economy represented by preference and endowment. Okay, that's the given thing. Of course, the preference gives it utility, right? You can start with utility and endowment. Okay, and what is the outcome of the system, right? The outcome system must be allocation, right? We start with some endowment, and after that, then they will, at the end, have consumption, right? It's each consumer will consume something, right? It's n vector, right? So we say consumer one, he can have n different consumption I as n different. So there's a vector of n, or you can write in matrix form. But I guess in economics, we will usually write vector, but you can also represent by matrix as well. But vector is maybe more convenient for our purpose. Now, so we first talk about what is feasible first, right? Because remember, allocation is the outcome of the system, right? Because they start with some endowment, they would trade each other, and what is allowable is called feasible. And feasible is very simple. It's just no one can have more than they totally what they have, right? Okay, there's no property right here. As long as I can confiscate everyone, right? And just reallocate, right? It's okay. Or they can freely trade. No matter what system you're using, they can't have more than they have, right? So that means that for each commodity, 1 up to n, adding up everyone's endowment, right? Look at commodity K, right? What there's a commodity K, right? You add up for every consumer what they have total, right? Must be bigger than in total what they consume, right? So they can allocate cannot be more than what they have, right? Or compare, you can write the matrix, right? And that is very simple, right? And in the undergrad, you should learn that actually is the actual box. I don't have actual box here, but let me draw it. If you still remember in the undergrad, if you ever learn, that is how you would draw the picture there. So let me draw that here because I think that's good to, oh, why there's no line? Maybe okay. Let me see if I can have a line over here. Not working. Let me draw it by hand. So suppose only two goodwill, okay? This is X11. So this is the agent 1, right? Agent 1, 2, right? So assume the two goodwill, right? So the x-axis is how much you want to allocate to 1, right? And y-axis is how much you allocate to 2, right? So Mr. 1 is here. Mr. 1 is here. Okay. So if you choose this point, that means that you give nothing to Mr. 1. Okay. So if you choose at a point there, then it depends on coordinate, right? Suppose you choose this point 1, 1, all right? That means that you give 1 to player to Mr. 1, good 1 unit of good 2 to Mr. 1, okay? So this is, you know very well the allocation in the consumer, right? There's nothing new there, okay? What's new there is you assume there's another woman. She's looking on the upward direction, okay? She's looking at this dimension, okay? And for her, this is x2, 1, and this is x2, 2, okay? If you give her this point, okay, from this coordinate, basically you give nothing to her, okay? This means 2 is over there, okay? Why I want to draw in this way? Because I can use the same point to represent the allocation. Why? Because the size of the box is a total endowment, okay? So the size of the box, total endowment on good 1, say for this box can be drawn in the way that this is E11 plus E21. This is total endowment. And particular, if I pick this point, okay, look at from this side, right? And this is will be actually x11, okay, you allocate, and the height from this will be x21, okay? And you look at from this perspective, okay, this will be x21, and this height will be x22, okay? The woman number 2 is looking at this height, and this is width. So every point in this, what we call the Edgeworth box, because invented by Edgeworth, is represent what is feasible, okay? So basically this rectangle is what is feasible in the society, right? The total resources is represent this rectangle, and anything within the box, actual box, is allowable, okay? So the question would be, we start from, say, this point, green is initial property right? And what should be the outcome, right? Of course, if you're a dictator, right, you can take any point, right? If they do not, they're slave, they belong to you, right? You have all property right, that's okay, right? But of course, you know, in the world, right, you can't really move things around, right? If remember, if there's a common production, you can't really move around, right? Because suppose they have to work hard to get this point, right? If you take away what should belong to him, right? Basically, maybe he get married, right? And the woman may take all the money at house, then give basically no money to him, right? Maybe this is feasible if when man is very happy, right? But what happens if you leave nothing to the man stop working, right? The Edgeworth box shrink, right? Then you can't really allocate things, right? But in this model, we assume that Mr. One is very happy, right? He's willing to give up, he's willing to work hard, even he don't have anything, right? So in that case, that's okay, right? But that is a problem we will talk about, okay? We will allow the property right, so we can't really take things from them, right? In this system, you have to be voluntary exchange. Later you will see. At least he should be happy there, okay? Otherwise, I mean, that is too simple, right? If you can say, okay, I can move this around feasibly, right? Any point, then it's not much problem to solve. Okay. Anyway, let's get back to the business. So this is the actual box. Okay, this is the thing. I think if you have studied in the undergrad, that's been there. Now we assume all the consumer, of course, follow what we have seen, right? That utility function, continuous, strong increasing, and straight cosine concave. And you ask why we need straight cosine concave? It's because that will lead us to have a demand function, and that will be unique, right? Because that will give us solving the utility maximization should be something you need, okay? But there will be something a little bit different from topic 1. The reason is because of you are not come up with single money. Remember, the problem we see the topic 1 is this part, P times EI, is a single number. You endow money at the beginning, right? But now, it's not, you start with not with money, you start with endowment, you start with goods. You have to sell the good in the market, right? So that is a little bit different, right? So it's different. So the problem is it going to be a nice solution there, right? So turn out to be, luckily, yes, okay? You can apply the same problem, right? And this still, because it's price sticker, so this is still a fixed amount to the consumer, okay? Do note that there's a big assumption here. It's the price sticker, right? So that's why P dot E, which is the income, right? Which is still exogenous, right? Although we don't use I, but now we have P, I think M, right? M in the notation, right? It's still the same thing, okay? So I hope this already there. Now the question is, we want to rely on the market to solve this problem. So what we want is, if everyone is looking at like a price sticker, okay, will the price itself sufficient to make everyone happy, in the sense that will there be a single price, okay, such that if everyone is price sticker and everyone is maximizing its utility, taking the price as given, will such a price, everyone is happy with the price. So if there's a price, clear the market, right? Because everyone is working or making decision based on price. Is there a single price such that everyone is happy with the system? By happy system means that no one want more than what they have in total. Okay? Is the price is good at allocating the resources in the system, respecting the property right of everyone. Everyone start with the endowment, and they look at the price, they do the trading, and everyone is happy with the outcome, given the price. No one can do more than the price, okay? And there's no shortage, and then no, so that's important, shortage, right? You have more good, it's not an issue, right? Because you have more good than what you have, the price becomes zero, right? But you have people want more than the thing at the price given, everyone's not very happy, right? Actually, it is the problem of the economy, if you say so, right? So that's why we define one thing called excess demand. This is the indicator where the system fails. How we define excess demand is given the price, okay? And the first item is the total demand, right? The right-hand side is the endowment, right? If this is positive, then the price is not doing the good job, right? Because everyone wants the same price. This is not a price that's not this satisfy the ideal price is equilibrium, right? The price should not be the one that is good. So as long as this is zero or negative, the price is okay, right? Of course, if negative means that you have more than you do, actually it will imply P is zero, right? It's free, okay? That's like rubbish is free, right? You can just pick up whatever, right? Or some kind of sour fruit, okay? Sour pears is free, right? I think we learned that in the primary school, right? 孔融让梨, and they talk about why there's a pear on the side road, easy to pick, because the pear must be very sour, right? No one pick it up, it's free, right? So that's the same idea here, okay? So we want this excess demand, right? For each good should be negative or zero, okay? So this is what we want, okay? But let's see what do we have in our system. If everyone is price sticker, if the preference what we have is continuous strong motor is quasi-concave, which is what we have already. First thing is this excess demand function will continuous in P, which means that if P changes continuously, the excess demand also changes continuously. Why? Because your demand is changed continuously with P, right? Because X is continuous P, so Z will be continuous P, right? Because this is not with the P at all, right? And second is homogeneity, which means that if you double the price, right, it's just no change. Because why? Because you double the price, everyone's income is just double, right? Because, right, it's because your income is based on P, right? So that's why the price is just a relative idea, right? So there's nothing new there. But I think the most important is called the Wawa's law, right? You remember Wawa's law is, we said, it just use up all the money, right? In this case, it's saying that price times excess demand is 0. What does that mean? It means that if two things multiply is 0, okay, and price is non-negative, right? Price must be 0 or positive, right? That means that if they add up to 0, right? So either this is 0 or this is 0, right? Okay, later you will see. Okay, this is very important. Which means that if there's no excess demand, so if the price is positive, okay, for the good there is positive price, excess demand will be 0, right? Something is valuable, the market must be perfectly clear, right? Demand equals supply, right? And if excess demand is negative, this price must be 0, right? Because price cannot go negative. Is that clear? So let me repeat the statement. Okay, if for the good, right, carry some positive price, you have to pay for that. It must be the case demand equal to supply, right? Supply is endowment, right? And if demand is less than the supply, it must be free. There's a free good there, right? So that's right. So that is the idea. Okay. But that is actually simply coming from people price sticking and consume optimizing, right? This will give it this already. That's very simple, right? It's idea, right? If something must be free, it must be more than enough, right? To satisfy every people want, right? There's no allocation problem. There's no, the first class in economics, there's no scarcity, right? If everything is available, okay. So I think I did that already. I'm not going to do the proof, okay? And one important thing is, okay, probably not so for our idea, okay, but it implies one thing, right? The multiply is 0. It means that if all market but one is clear, the last one also clear. Okay, so that is something very interesting result. But of course, it's not too much use for our purpose. Okay, so let me define this, and we have a break because this is a very important definition. Okay, and we already said already. So if you rely price to allocate good, what is equilibrium or what the outcome is? It must be the case that the price is equilibrium and no one wants more than what is available, right? You can set any price, but what is the price? What should be the price? The price should be in the case no one want more than total they have, different the price. And this is the price that we say this is the stable price, a good price. And Lavoisier will say this is a equilibrium price. That's called the Lavoisier equilibrium. It's just like the price. And if you have continuous strong monotone, straight concave, you have already. Endowment are positive for everyone. Everyone has some money there. And there will exist, this will prove, okay, there is such a price, okay, so that this is no one want more than what they have. So the system is in a nice form. Okay. So there will be if everyone is price taking, okay. So I don't know where it come from. It can be more than one, but there will be a price, okay. If you're able to find it, so everyone is very happy, okay. In the sense that people are maximizing their utility, right? So everyone is at least he need not trade, right? He can happy with what they have, right? And by trading, actually, he's getting happier, right? Because we are not allowed to force him to surrender his endowment, right? Everyone is maximizing his utility, right? So given this price, okay, everyone is at least happy compared to what they have already. Okay, he can be alone, not trading, but he entered the market, okay, interact with other people, he's very happy. Okay, and this price, no one would want more than what is that set there, right? If we allow people to trade, right? If the market is open, everyone can trade, right? That means that excess demand will be negative or zero, right? Remember the idea, right? It's price taking, right? So everyone can trade, okay? And there's no need to do rationing, right? Otherwise, if this is not satisfied and use the price, you have to use other idea, right? If the price is below the market price, you have to do the rationing, right? I think in the old days, right? At least in China, right, or other place, right? The price is so cheap, right? Then what happened is not everyone can buy anything, right? If you want to buy a meat, you can't actually have the money and go to the butcher. I want a butter and I want this meat. No, you have to have a meat coupon before you can buy. Even the price, you can't really buy it, right? So you can't really have that, even that. So that's why it's very important. We want the market to work by itself without any external force, only the price itself, right? So if you allow people to trade, you don't have any restriction. It must be the case that the excess demand has to be zero or negative, right? Because everyone can trade, right? You are not saying that you have to get a stamp to trade, okay? So that is the main idea. So we want to prove that, okay, there's a price, okay, then that will be an equilibrium, okay? We will try to do the little proof. I'm not going to go to every single step, but give you some idea how this is being proved. I think it's very elegant, but we don't spend too much time on that. Okay, but we'll have a break of 15 minutes. In the meantime, let me do you reply. Let's have a 15 minutes break. So resume at 10:40. Okay. And I know next Monday is mid-autumn. So I'll bring you some small gift so you can take something to celebrate. You can do some draw. You can close your eye and draw something. It's something like that. That's what I bring to you guys. Want something to you know, or you can go surprise. Something I like very much. Like it also. Okay. Big autumn festival. Small people. Get something. Want something? You mean autumn festival? More? Almond. Different type of almond. This is something I really like much. I have a lot in office. That's my favorite. Especially I like it honey style. This is the favorite. Good for your brain because you like it too much. Study so have this increase your IQ. I don't know, but yeah, enjoy it. 1040.
还有这个它是2011年开始，就是我们可以看见这个 system， 然后好多，那个但是反差的，今年的什么3个人，也是其实这如果，然后我听AI 情况。AI 是好 AI 是，这个呢就说了一个关键，就说了，因为 AI 这个就是现在很多什么博弈的那个另外一个情况博弈的对这种需求是这种。对，不是对，然后又什么样的点达不到，那不行，然后这样不管，对，AI 是这样的。它这个就是我认为它比较有意思的地方在于，它是至少我目前看到的第一篇去针对 LM 这种技术架构的一个特征型包容。那我想这定义有点什么，就是关键在于它是一个像 OCT 的呈现一个思想区，只要看去就是这样，还会看出是，这是一个高点思考。不是按照那个单纯方式，就是我们就是在对，对，所以这么好是的，就是对，他们就是这个那个，他有一个具体的词，他跟这个对这个有具体的词，就是我就听他可能就不看他造型和那个第二个西红柿叶，然后后面说第二个那边可能他我要看。但是我觉得最关键在于我想看到就是有那种真的，因为就是一个当然这种观点就是错，万一老你下一秒没干就，万一以后有人沟通可能，就这种机构架构，你知道不了。所以，当然它挺有意思，因为很多人我感觉军工老幺就是说很多方式，当然这个方式，这个是历史啊，好，我不是很，还有这一个点，就是家长开什么，大概出来就这名字，当然啊。是我没啥，我不知道，我们看一下 Actuarial， 啊，对，就是他说这个 strategic proof 的 management 是困难，是计算上困难的问题啊，就是说这个问题在计算上课程，然后最近呢，深度学习这题在做一个替代的方法，这个方法需要语音知识和调参的技术，我不知道有没有。在这个当中，第三个话，我这个大的意思加入到进化的过程，然后它会生成机制，就它是按生成机制，一个进化。对，我不知道它是怎么去生成和推理，而且还能生成这个理论上可行的机制。然后下面就是他们的实验，这个光看，就是主要就在这儿，还有怎么分成，然后这个还有它首先有一个第一个档案，一个光 set， 一个摸的预算力。对，我刚开始公司比较包括会看看我知道，然后 prompt 是把它改成 prompt 就是用表示这种，哎，这个带几道数学题， 就是你好像你把一个很难的数学题用你写好，然后来告诉你。但是这个依然没有说就是他去深入到 F，最后归类的都要做这个，因为我们做的别的 F 有一定能力都，所以它这个门槛好，应该准备高。或者是 empirical 的 info， 但是当时有就通了有，但是它的那个他们是研究 AI 生成内容的 MIT， 然后具体来讲，哦，可能广告的呢，然后在他们手。我把消耗对大人做，哦，这个是我是哦，而且对，MS 是可以在都不能，哦，是 MS 我在这个反应，因为你可以开它哦，你看，他们最重要的其实你怎么工作啊？哇，这个。当时，但是当时啊，但是没有一个状态，没有一个内部的心理的状态，像病人或者吧，其实是他们可能享受的是这个状态是第三。这个人的这个对，然后他是这么说的，因为现在的答案很好，一个的。风险太高，这个风险是被自治规设上，这个为什么要切的？好像说这种 open option 是在通常在某种是不成。来说我的这个当然对，为什么应该就是20年讲，现在广告，当时2008他们是去研究是或者如何去跟这种市场的 AI 的去研究它 AI 天道发展的。最高的发展会，说很多路给选 AI 都是选看为什么这就是你们找的三或者是变化的，这里面是你考完的。民宿的时候嘛，3、4。
So, five of you have filled in. So let's see what do we have. Is it fast or slow? Let's check it out. So, can we consider that most phenomena in real life current equilibrium? That's the view of economics. They think about that every time we're in equilibrium, but we're disrupted by new information, right? That's the current predominant view of economists. And of course, uh, this is not the universal view. That is what actually what the Keynes, John Maynard Keynes said. In the long run, we are all dead, right? And economists think about, I mean, in the word, right? Just like he said, economists think about too easy because everything equilibrium, but in the when to get the equilibrium, we are all dead already, right? But so that means that in some sense, like how to get the equilibrium is an issue. This equilibrium thing and how equilibrium be arrived is a big concern, and probably many of you would know how the equilibrium get to the equilibrium is an issue, right? And we can switch from one equilibrium to the other, right? That can be an issue as well, and that is something that is also that's why in the 90s people talk about evolutionary equilibrium, right? It's from the game theory. It's like how you progress from one to the other and look at engineering. They also look at how dynamics, okay? But in our class, we call it statics. So the reason is not because we don't care about dynamics is because of mathematical complexity, right? And that's why these days AI, or what we call the agent-based modeling, allow you to study those dynamics in explicit form. Okay, of course, this will be something in the future, and as long as computational thing is getting easier, that will be there. So I hope I answer that question. Of course, this is something very big, very deep as well, right? And the main thing is like in financial market, the price move all the time. It's an equilibrium, right? In that case, probably you will look at how agents think and how they interact, right? Because in financial market, they say every time this information comes in, right? The one way to think about the classical framework is this: every time it's equilibrium, but you have new information, people will react to that, right? Take some time for the whole system to consolidate, and actually every day at the end, it just take a few days to get to equilibrium. And indeed, that's not too much far away from that. I think the recent paper, I mean, written by our colleague in the accounting, school of accounting, talk about when there's a new information about a stock, okay, and released in Twitter, and of course, in a few years ago, and then talk about that in Twitters, it only take 15 minutes for the market to learn, and equilibrium arrive, okay. And before the Twitter, people use Bloomberg terminal. It actually took them, I forgot the day, 1 hour for the price to get to equilibrium. Okay, but that is if you think the financial markets people most look at, yes, right, the equilibrium adjustment. But for many things, adjustment take very long time. Okay, financial market is very fast because it's very liquid, right? But look at how and why financial crisis take a long time. Right? Look at Japan, right? Since 1990s, right, the economy is bad, and people take a lot of debt, and you take like 30 years, right, for them actually get back to the system, right? Because there have been recession, there have been zero interest rates for a very long period of time. Okay, and you can say in the macro perspective, it's like in this equilibrium for 30 years, and now get back to normal, right? So yeah, I mean that's how you think about the world, and of course, there's another concept about actually can question about this is fundamentally is about are people rational, right? And the idea is there's only one way to be rational, but there are the 1,000 ways people can get crazy, right? So how can you have model to model crazy? Of course, you have each way of craziness, you can model it, right? There's so many irrational model or boundary rationality model because there are many ways to do it. Same in equilibrium. There's only one way, or we limit the way can the market be equilibrium. But there's many ways you can say the market in disequilibrium. So we have some benchmark to study equilibrium first, and in your particular application, you talk about disequilibrium. That will be also allowed, right? Because you can say the market doesn't adjust easily, and many of you will study the search model, right? Then this information constraint, right? Then you still have equilibrium, right there. So it is I guess it's a first order approximation. I think in the real world it's equilibrium, okay? But of course, how long does it take to equilibrium? Short run and long run, there's a ASO there, right? You all run in last class, right? The short run thing, short run equilibrium, long equilibrium, right? Whether the production, there's a fixed factor or there's no, right? So in the short run, there's equilibrium, long equilibrium, okay? So I guess it's pretty much okay because empirically we found that this kind of analysis is kind of okay, okay? It's not something deviate too much from what we think. So you do have a very big philosophical question goes on here. But that's what economists think, right? People think about economic approach can study how people do the crime, how many baby going to make home economics, right? People do the crime economics, family and all that stuff. So I guess that is what people think in this way, right? If you ask people in physics, right, everything is in equilibrium. Right? Engineering, they would agree that would happen, right? But of course, there are things is moving around is equilibrium as well, right? The second is, thank you for saying the lecture is good because I try to improve if you let me know things and I guess I said in the first class, our class is basically very similar to the example, the green thing, okay? So the red thing, right? You do the assignment, you know what's going on. That's basically the assignments, okay? The assignment, will be the thing we ask in exam. Otherwise, why we ask you to do assignment, right? We will be somewhat same level of as assignment, or sometimes even easier. But I think we will pitch the same level as assignment. Maybe I will have one small sub question is more difficult, but otherwise it will be same level as what we have seen. Okay, it's not something too difficult from. It's focused on solving the model, not proving. I don't think I'll ask the proof, but I will just do the computation. So I give you a model. I ask you, say, suppose consumer. I give the consumer preference. I ask you to solve different type of function. That's what I do in the assignment 1. You say assignment 2 as well. I will give you some firm. Firm production technology. I ask you to do cost minimization, so on and so forth. Right? And general equilibrium, as you will see in the next assignment, or partial equilibrium, I will ask you to solve Carnot model, Southfield-Burchard model. Okay? Basically, I will ask you to actually solve the model because this is what you need if you ever do theory, right? Of course, I can ask what kind of assumption behind this result, but I guess I already taught in the class, so I don't need to repeat that part. I think that's easy to get anyway. So solving the model, I think that's the most important thing. So for this class, of course, in the class I emphasize what is the assumption behind we solve this model. That's again this very important part as well. So I don't think there's an issue there. Everyone is perfect. Equilibrium, Wawa's law, yes. Everyone said this. Okay, the speed is okay. Not that bad. Following is okay. Anything to say? Nothing. Okay, that's good. I'm very glad that you're all here. Okay. So it's good that you asked the question because otherwise I don't really know. Okay. And probably I guess one of you may ask, is it relevant to the real world? Does it exist a surprise? The answer is more or less the same. I think it's yes, because I think in the short run at least the price doesn't change a lot. That's correct, right? And there's a big concern, not right now, but I think in the old days, especially in World War I and World War II, after the failure of capitalism, people did think about whether market system would work, because actually we look at why Adolf Hitler get into the power is because the price increase substantially, right? There's a huge inflation goes on, and people actually question, is there such a price that actually can allocate goods, right? And actually, right, there's some issue there, right, in using the simple price system. But anyway, that's what Keynes said, right? People are not really rational. You need a government to do things, right? Because in a recession, no one wants to spend money, right? Government need to be the guy who spend money. But anyway, that is something. There's a aggregate demand problem. But anyway, that's not a concern. We talk about well function in the market, right? So let me talk about this simple proof. I don't want to go into every single detail because that involves a trick, what we call a fixed point theorem. The reason I want to talk about this proof is I want to talk about very important theorem that will prove existence. That's called the fixed point theorem. The idea, we'll talk about that very quickly. So we'll just take 5 or 10 minutes to talk about this proof. Don't worry, this is a black one, so it's technical, so you don't have to understand for your exam, but it's good to know what's going on. So the proof is, the first part is rely on the idea that is homogeneous in degree 0 in the price, okay, for the excess demand. Okay, in that case, because the price itself doesn't matter, it's the relative price, because you double the price doesn't change anything. Okay, so you can normalize the price to 1. So that is why we talk about the normalization. Remember, we talked about it before the break. Is this homogeneity, you multiply per price by every proportion, the z will be still the same. So it doesn't really matter the price. So that's why there exists a price vector. Why? Because if this price vector solves the model, you double the price, still solve the model. Okay, so the first thing is not unique. Actually, before we talk about existence, if there's exist, actually it cannot be unique because double the price, triple the price, quarter the price would still solve the model. Okay, but first, because of the fact that doesn't really matter, we can normalize to 1. Okay, and you multiply this to 2 times the same answer, so we normalize to 1. And because normalize to 1, that means that or non-negative, actually there's a notation in math, it's called simplex, which means that this notation, right? n-1 simplex. Sometimes n-1 I use n, but doesn't really matter. If n is this one, but anyway, the mapping is from basically n-1, so n-1. n-1 is from n-1 simplex to n, because n-1 means because you have n-1 price, the last one is already 1 minus them, so it's n-, I think it should be n-1 notation, because I think I switch back and forth, so it's a little bit confusing, but this is what it is. Okay, it's just sum the price to 1. So here is the biggest trick goes on here. Okay, and turn out this trick is also very intuitive. Okay, so the trick here is how can you prove there exists as a price? Okay, and there's a magic step here. Okay, now you see the magic. Okay, I'm showing you the magic. It's not something. How you get this is a trial and error, but let's see the magic. Okay, the magic here is what we call, let's see this called the adjustment function there. Okay, this g of k. Okay, what it is something you define very quickly. What it is this function is from simplex to simplex. Okay, so it gives you a price, I give you something. Okay, what it is a fraction. What's denominator? Denominator is 1, which is sum of the price. Okay, and what is the second part? Is sum of or either 0 or excess demand. Okay, so what does it mean is if you have negative, it doesn't really matter, right? Because it will become 0, right? But if positive, you'll be there, right? So that means that when it's okay, if everything is okay, it's 0. If that's good, it's no problem, it's 0. If that's good, there's some problem, you will have positive. Okay, so it will be, if no problem, this is 0. Okay, now what is numerator? Numerator is price, okay, over and plus the same term, right? What does that mean? Okay, it means that, look at this, if everything is all right, it means that the max thing is 0. Okay, then the g function, you give the price, will give you the same thing. Right? So let me repeat. If the market, there's no excess demand, okay, this price under the g function will give the better price. Right? Right? So that is the idea. Okay, first, this is the function, which if we want a Lavoisier equilibrium, okay, this price, okay, under the function g will give you the same thing. Okay, g of p is equal to p. Okay, that is called, in math we call it the fixed point. Right? You give me what, I give the same thing. Okay, that's why the fixed point idea. Okay, and you will try to look at what are we doing. Okay, what are we doing here? Okay, and you can look at the intuition of the Lavoisier equilibrium. Right? If something in excess demand, which means that the price is not high enough, right? Because the price is high enough, you would drive the demand lower. Okay, so you can see this is what happened in the formula, right? So if only a particular good is excess demand, okay, other good are 0, you have some positive z, right? The z is positive. Okay, and in that case, look at how this formula works is if you are above, then the price adjusts higher. Okay, the g function basically tells you that you give the price. If you have excess demand, the g will tell you how to adjust. Okay, basic adjustment, right? And you adjust until that would happen. Okay, that's what happened. As I said, excess demand, there's a positive, then this gk should be bigger than the pk, right? The other way around, don't change. Let's say again. there's a guy over there. We call it the guy called G. Okay? If give him the price. Okay? If give him the price, if no one want more than what they have, I don't change this price. Okay? If there are people want more they want, I raise the price. They actually is what we call the Wawasa auctioneer, right? Everyone tell me this auctioneer, I announce the price. Good one, $5, good two, $10, so on and so forth. Everyone report how many units you want. Okay? I try to compute everyone's wants together. If adding up all of your demand is less than what I have, that's okay. I don't change my price. If everyone demand more than what I have, I raise the price. That's what the G is doing. Okay? And when I'm done is I don't do any changes. Okay? What you announce is not more than this is what I have. Okay? So this is what it is doing. Okay? This G is the guy. Actually, same as the one oscillator. Change the price up. Okay? Basically, you can imagine start from 0 the price, right? You keep increasing the price until this thing will satisfy. Okay? That is something you can imagine that's how this is being done, right? Or you can start from infinite price and keep dropping until things done. Okay? You can easily start from there. Okay? It's a price adjustment. And you can see this. You give me a price under a function, give you back the same value. It's called the fixed point theorem. And that must, there are many things that's called the power fixed point theorem. You always guarantee, okay, as long as you have a continuous function in a convex compact subset. Okay, I mean, this is a little bit complicated, but let me explain in this idea. Okay, let me do the simplest Kotakane fixed point theorem. What it said is the following. Consider the following. Okay, you have a univariate function f, okay, that's mapping from ECS from 0, 1, from 0 to 1, okay, map to 0 to 1, okay? Okay, that means that you have a number 0 to 1 here, okay, and 0 to 1, okay? So this is the mapping to itself, okay? Okay, this is the box, right? You pick any number from 0 to 1, your function must be between 0 to 1, okay? This f must be bounded because f must be 0 to 1, right? You map to itself, okay? And what do you mean fixed point? Fixed point means that look at the 45-degree line, okay? 45-degree line. This 45-degree line. Okay? I claim, actually this is the Kotakane fixed point theorem, is you try to have a continuous function f, okay? Function f. Give me a point here, you give me a point on the y-axis, right? So this is a function. You try to draw a line, it's continuous, constant f. It must cut through this 45-degree line, no matter how you draw it. There must be a fixed point. That will point that f of x is x. Okay? So that's fixed point is f of x. So there's no way you can run away. So there must exist some x that f of x is equal to x, right? And of course, x is between 0 to 1, right? So this is the fixed point theorem, okay? And this holds for, in our case, because we want P is equal to GP, right? So that's continuous. So how can you not there, right? Suppose you are in beginning, you are actually f of 0 is 0, then you're done, right? Suppose you are not, f0 is bigger than 0, so you start from here, okay? You try to draw a line, but remember you can't jump. So you can have to move up and down, what you do, doesn't really matter, okay? You can't jump. So what you can do, if you don't touch before 1, at the end you have to do it at the end, right? So if you have to touch it somewhere, right? Right? Because if F1 is 1, you're done. If F1 is 1, you have to go to somewhere here, right? And from somewhere to somewhere here, you must cut through it. Okay? So that is the Kotakane fixed point theorem. Okay? And this holds when we have not just one dimension, multiple dimension, okay? and need not be one-to-one, but as long as this is a convex compact subset, okay, need not be Euclidean space. It's very general concept. Okay, so that means that, but this is the proof behind, right? So it's construction. So basically, most of the proof before 2010 is based on this line of proof. Basically, all the different kind of fixed point theorem. I think since 2010, they can do differential geometry, do the manifold, do a much more complicated proof. But before that, I mean, this is the method used for 50 years, okay? Based on the fixed point theorem. Okay, so always exists. But the idea is very simple, right? Basically, you start from a very low price, you keep increasing, right, until it's over, right? But the only thing that concerns us is why this is a concern, right? You can imagine, well, I keep increasing the price and we're over, right? But the problem is if you increase price for one thing, the demand will go to the other good, right? So will there be something stop? It's not entirely clear, right? Because suppose good now is you start with some price, good one is clear, good two is not, right? You increase the price of good two, right? But you increase the price, you reduce the demand of good two, right? But that means that people will buy good one, right? Then should you increase good one then? If you increase good one, we go back to good two, right? So can there be something stop here? Not entirely clear, right? So that is the reason why you actually need the proof to prove that this process must end somewhere, right? Otherwise, okay, because you can price it to infinity, right? So that means that turn out that they exist, okay? Which is surprising because actually economists actually try to solve this problem for a very long time. Actually, in the 1900, they do not know how to solve this problem. They think about every demand is linear, and you count number of equation, number unknown, right? Linear equation, number of unknown, then you can solve a problem. But this is only true if a linear demand, right? If there's no linear demand, which is not linear in many cases, then how can you solve the problem? And it took 30 to 40 years to figure this out. Okay, it's not something trivial. So I don't expect you to understand this immediately because it took economists for 30 to 40 years to understand this. Okay, and of course, this is only done by saying that there's a price. It's not done yet because we can actually illustrate that is a Lavoisian price. And from here, this is simply a construction. Why? Because this price, okay, you just multiply, look, remember the G function there, okay, and you apply this, you just multiply this to the right-hand side, this cancel out, so just this equal to this guy, this equal to this times this. So that's how you get that line here, okay? And then there's a trick here. You multiply z to here, okay? And later you see why I do that, because that's Lavoisian's law. Z times P is 0. Okay? Later you will see, right? And multiply that. Okay? You summing all the thing. We get a 0 on the left-hand side. Okay? And remember, this is 0 times the same thing, right? It's either 0 or a square, right? And square must be add to 0, must be non-negative, then we're done. Okay, so that's the proof. Okay, so it's not something terribly difficult. There's some math behind, but I try to illustrate that the key step is the thing about why the fixed point there, and fixed point idea is basically the Lavoisian adjustment, right? There's some adjustment over there. And tell this adjustment is deliver what we want, and we're done. Okay, and of course, as I told you, this took 30 years for economists to figure out. So it's like a magic. And indeed, it's a magic if you first time to learn it. Okay? And I'm still amazed by this. No matter how many times I teach this one, I'm still amazed how they think about this. It's like, how can they think about this? It's like magic. Okay? Of course, once in a lifetime, you saw some magic, right? Is that okay? Is that okay for this one? I mean, I said, don't worry if you don't get it, because I think when the first time I learned this is I don't appreciate that. Why there's a fixed point? Why you have some magic function, right? But turn out that there's some trick. You just like when you solve a Bellman equation, there's some trick there. So then the trick you can guess how can it comes about. Okay, there's some magic. Someone thought about that. Okay, you don't have to you don't do the proof, so don't worry about that. But this is advanced PhD level, so we have to talk about some proof, right? Otherwise, what are we doing? You learn something there, okay? So just to remind you, there are one-term price equilibrium. But in some textbook, they will talk about equilibrium more than price because remember, we want to care about the allocation at the end, right? Price is just a mechanism or the way to allocate, right? So this is the market, okay? And the allocation will be just a unit, right? Because this is, if you give the price, that this will be the unit one, okay? According to our equilibrium, right? Because you have the caustic concave preference, right? And the price, the allocation will be a unit, okay? Because give the price, right? If you don't have this assumption on utility, then you have more than one bundle that maximize your utility. So as long as your demand is well behaved, right? You have the demand function, then you don't have problem. Okay? And there will be one. Now, once we're done, we want to know how good is this equilibrium, right? We just know there's a price that clears the market and respect everyone's property right, okay? The question is it good? Is it good enough, right? And how can we analyze this? The first thing to do is to understand the very first concept in economics is called Pareto efficiency, okay? And this is the one that no one actually, at least no economist would say no to this, is if you can do something better without harming anyone, you should do it. Okay? It's income efficient, right? What it is if there's allocation, it's Pareto efficient. If there's no other allocation, which is feasible, where F is feasible, right? Such that no one is worse off, and someone is slightly better off, right? So if there's something that improve someone without harming the others, that is not efficient, right? On the other hand, it doesn't mean the following. It's efficient if you improve someone, you have to harm others. Okay? So that is the idea of efficient, right? So I guess that is okay, right? Of course, those of you who study psychology would disagree with that, right? People derive happiness or fairness idea, right? Because if we are different, you earn more than I do, I'm very unhappy, right? Let's burn together, right? Let's pretend we don't do good, right? So that is some idea of it's better to be poor together, right? Rather than you rich, I'm poor, right? So that is some. But if you take the idea that okay, if you get rich without harming others, it's okay, right? Or but sometimes actually we want to get all the poor, right? So just like the following, right? If everyone got C, maybe it's okay, right? But or put it this way, right? But if somebody got A and everyone got C, then no people will get very happy, right? So that is the idea, right? But simply look at efficiency, okay? This is what we have, okay? We don't care about fairness by this concept alone, right? But of course, some people criticize this part, right? It's only efficiency is focused on this one, okay? But at least this is what the first worthwhile theorem said, is if, okay, under assumption actually weaker is local non-satiation, but we have all that already because it's monotonic. Okay, local non-satiable actually is weaker than monotonic. Local non-satiation means that for every bundle, okay, you're able to find something nearby that's better than the bundle. Okay, Non-monotonic means that you can go to the northeast direction, right? Northeast is always better. Non-satiate actually allow you to go to any direction. That's better. Let me write that down because this is something that we didn't talk about this. Okay. So monotonic means that you give you a bundle, which is better bundle, you go north, and go east is always better off, right? So that means that it's always good go to this direction. And no colon satiated means that, okay, you don't have to say this direction. No colon satiated means any direction, there exists one direction, you go, it's better off. Okay? There's no, locally, there's no point that's highest. Okay? So that means that if you look at the contour map there, there's no dot over here. There's no a local minimum here. There's a global maximum, global local minimum is not in any there. Okay. So, but anyway, we assume monotonic anyway, so that's trivial. If you have monotonicity, more is better. Already, we have the following. A velocity equilibrium must be Pareto efficient. So it means that you allocate goods using price, and if you're a price taker, in that case, there's no way you can improve the price system without harming anyone. Okay? Okay, that is the idea. Okay? Let me repeat. If you consider a market that allocate resources based on price, okay? In this equilibrium, there's no way you can improve some people without harming others. Or in other words, market equilibrium is already good in terms of efficiency. Okay? Is that okay? So that is actually the first welfare theorem. Okay? Actually give the idea that, okay, market at least is not bad. Okay? Doesn't say anything whether good, but it's not bad in terms of efficiency. Is it fair? Other issue. But at least it's efficient. Okay? So that is the first thing. And that's why it's called first welfare theorem is so important, right? Because people are so nervous at that time. I told you the history, right? During the time of Soviet Union, actually this is invented in the, I think 50, 60s, right? At that time, Soviet Union have the first astronaut in the sky, in the space, and people in the US is very nervous, okay? And they have this theorem, they feel very safe now because market is also very good, right? Maybe the commerce is okay, right? Maybe it's okay, but at least they figure out market is not bad, okay? Right? And the proof, I don't want to talk about the proof because we don't have time for that, okay? If you have time, we can come back, okay? But I guess probably, I mean, because the proof is basically involves some manipulation of inequality. I don't know, if we have time at the end, we'll talk about that, okay? Maybe you have time, but I mean, if you have time, we go back after I finish everything, okay? But I think it's good to look at this field, but let's see if time because I don't want to cover too many theorems, then you feel overwhelmed. But let me talk about the second welfare theorem with a break, okay? The second welfare theorem is opposite case, right? We said market is efficient, okay? And the second welfare theorem said, okay, if we are able, because then turn out later you will see that many outcomes are pretty efficient. Okay, but let me first talk about pretty efficient joy graph first because that would be useful. Okay, let me draw a graph first. So let me go back to this slide. Okay, here. What is Pareto efficient? Okay, Pareto efficient means that there's no way you can improve without harming others. Okay, let's draw a picture. Suppose this is the green one is want to see. Is green one Pareto efficient? How can we talk about this? Okay, we figure out that is there any way you can move without harming the other? Okay, so let's draw indifference curve to this. First guy, suppose our indifference curve is like this. Okay, sorry for the drawing, but I hope you know what I'm drawing. This indifference curve, but you can draw more, right? You can draw more, right? You can draw more. Okay. We assume the cosecant convex, right? It's a convex preference. Okay, so go up is better. Okay, fine. Is that okay, right? So this Mr. 1 go in the northeast direction is better. Okay, look at Miss 2. Miss 2 is on the top upper corner. Okay, his preference look like this, okay? Instead of this side. Okay, look at this guy. So let's look at this. I use the what color? So I use this. Okay, the millimeter like this, right? Okay, maybe do it. Okay. So can you tell me, is this efficient or not? Productive or not? Yes or no? Who think this is productive efficient? Raise your hand. Who thinks it's not efficient? Raise your hand. Okay. So no one answered the question. So the answer is this is not productive efficient. Why? I will tell you that there's what we call productive improvement. There will be sets of allocation that everyone actually better. Where? Is in here. In this area. Why? Look at this green area. It's above the green area, right? This orange area is good for Mr. 1, right? Anything in the green, actually everything above the green is better for 1, right? He will be happy if you go to green. Let's go to the orange area, right? Look at Miss 2. Miss 2 is loving everything on this side, right? So anything below the red one is happier, okay? Orange is better for number 1 and number 2, right? So that means that this is not Pareto efficient, okay? That means that if your indifference curve is differentiable, every Pareto efficient have to be tangent to each other. So the MRS is same for both, right? Why is not? Because MRS is not the same. There's some way they can trade to each other. So see, right? There is a here. Let me the trick. Okay, is because the marginal substitution between the two agents in this model is not the same. They will be able to find some way to exchange, right? So Pareto efficient imply MRS must be same for everyone. Okay. At least in this case, right? Must be. It's not that you can see this one, the slope is not the same. They must be able to find something to trade. Okay. Why? Because MRS is internal exchange within himself or herself, right? Only if they can't figure out how to trade, the rates are the same for everyone. There's no way to trade further, right? Because right, you can reallocate their resources. Okay. So this is not. Is that clear? Now, let me talk about the second welfare theorem. First welfare theorem said there will be a price which equate everyone MRS, right? That is exactly what it means, right? There's a price that will equate everyone MRS. That's what actually this is the implication of the Welsh welfare theorem. There exists a price for every single good, so that the MRS for each one is equal to the price ratio. Okay, that's a thing. Okay, and this price actually allow us to coordinate, right? That's a very deep idea, right? This is a single price, a market. Actually, by everyone's interaction, everyone allowed to trade, the MRS is equal to everyone. Okay, is that clear? Okay, and that's actually the famous statement of people talk about Apple product, right? The Apple product is expensive. The problem is not Apple, right? iPhone expensive is the problem is not iPhone. is you, right? What does that mean, right? It means that you don't have enough endowment, right? The price is good to clear the market, right? So the same idea is Pareto efficient, right? Now go back to the statement. We'll talk about this detail of the proof. It will the break is second welfare theorem. Say the following: there are many Pareto efficient allocation, right? Because you look at the actual box, there are many, right? And depend on where you start, right? So because remember, Pareto efficient doesn't require you to say where you start, right? Pareto efficient is given the endowment you start, right? There's a many way, okay? But you can have different. So what I said is, suppose you start with economy, right? There is a Pareto efficient, right? So that means that if you look at this one, okay, start from this one, right? There must be something in the orange is good, right? But not everyone orange is good, but at least orange is the one that candidate, right? You can go ahead, but you can try to see maybe this point, they tangent to each other. There will be actually a bunch of point that is Pareto efficient, right? Not just one, but there's many, more than one, right? You can pick a lot of point. Actually, there's a line there. Actually, many point will be Pareto efficient, okay? And the question is like, there's so many points, right? Is there any way that, okay, you can achieve it using the market? Okay. And this means that, okay, we can do it, right? For every price that we could rise equilibrium. But the idea is there are other points, right? Potentially, you think the initial property right is not right, right? You want to achieve this particular point and that particular point, so on and so forth. Okay. But maybe you think initially someone had a lot of money and I'm very poor, right? So Ma Yun and I, right, we together have many $1 billion on average, right? But he has so much, I have so little, right? So maybe he should give me some money, right? He give me some $1 billion, will be okay, right? Then maybe we start from this point, right? I'm very poor. He's very rich, right? Maybe we should move somewhere in the middle, right? Get rich together, 共同富裕, right? Right? So how to see this, okay? And the second welfare said that if we're able to move around our money, okay, some assumption, right? But without people get angry, right? Just without loss, right? Because endowment, right? Because as I said at the beginning, you can't easily move endowment because endowment we don't model is people work hard at the background. You can't easily actually do it. But I suppose we forget about this. This money drop from the sky, right? Suppose we can allocate it, and as long as we can move this around, okay, we can achieve every Pareto efficient outcome. So if you really want Pareto efficient, okay, you can always rely on the market, okay, as long as you can move money around, okay. It means that government really need not to solve how actual allocation works. We can still rely on the market, okay, as long as there's some redistribution goes on, okay, as long as the tax system is sufficient, okay, we can do whatever we like without creating waste. Okay, of course, moving around the dock, moving around endowment can be wasteful, but if we don't think about this point, okay, we allocation the endowment, then we let the market work to allocate again. Okay? That is what happened in the current system in the society, right? We believe that it still requires the market to solve the allocation problem, but we have welfare system and taxation to move our endowment, okay? And in that case, that we can still have a nice result, right? And That's what happened, right? In the 90 in the 1980s in China, right? Regardless of the black cat or white cat, the cat that will catch the mice is good, right? That's what happened, right? We don't care about too much about the how the allocation in actual it works, right? The government focus on reallocation of endowment, right? The government should not involve in how to allocate the good. We just reallocate tax, right? Money, endowment, not exactly how the market work, how the price being set. Okay, so this is the second welfare freedom that underline what happened in these days in the U.S. or in the Western country, right? Even in China, it's like this, right? Probably only thing is still not using this is maybe North Korea or Iran, right? Or those, even Iran also is price, uh, but that is basically what happened in this world, right? Of course, the question is, how can you move around endowment is something, a big thing, public economics, right? How can you move around things? But let the price work is very useful. And indeed, you may ask, is there anything related to business? Yes, indeed, yes. That's what happened in a lot of big company, right? When within company they trade, right? They actually allow price system to work, right? When you ask a, I think the same as, I think in Intel they do this. If the Intel research department asks the chip to produce, actually they charge the department like this. I mean, actually same in the school. If we want to book a classroom, we have to pay, right? That's actually within the company, actually people charge for different action, right? Suppose basically if you go to take course outside the B school, right, we get charged for you to do so, right? So if you take something from other school or you need some IT service, and actually we got charged for doing that. Okay, so it's that's what happened. Okay, price is also used in allocation within company, right? There's a hidden budget, all right, between because you want to evaluate how good the department is doing, right, or how good the division is doing, right? Actually, between different parts, they are charging, right? Just like if a company require IT support, right, the IT which will build internally a business unit, right? Why? It's like this, right? Price actually can solve the problem efficiently. Otherwise, everyone asks for IT help. The IT has no way to satisfy everyone wants, right? We'll excess demand, right? As long as the price right, everything will solve correctly. Okay, so rely on the price is something okay, right? We don't talk about how to allocate this, right? How to allocate the endowment, right? But once we allocate endowment, then we let the market works. Okay, so this is second welfare field. Okay, sorry for overrunning a bit. Let's have a 15 minutes break. We'll resume at 11:50. Okay, and then hopefully we should be able to finish the rest of 10 or 8 slides. So we cover the most important two theorem, welfare theorem. So I hope convince you that market is good. I'm not doing you reply because I think it's already too overwhelmed. So take a rest. If you have a question, you can just tell me. I'm staying around to answer the question you may have.
博士我还记得拿那个，然后哦，毕业典礼也可以到对对。是，我俩线上，我俩没有，刚才真的有存在，都是的存在。对，其实对我来讲一天也能对我。然后快的，自己画，但是他那我觉得他以前不一样，就是画作和类似。对啊，对，区间，对对啊，均分20，还有10次吧，就是100，按均分20是30分拿到20，这个均分是啊，如果是30，均分是分是30，那你说最高60，这个也还是30，我去你问他是不是跟你问他不如看到往年，看看针对找上帝。面向测试题效果很好，不过不太大。我会找2个人，不是那么说一分早晚，真的不是，以前是高中啊之类的，就是考的，没有去考量。但是去多年了，应该是。在上课，但他很死硬。 是就是觉得更年轻一点，我就看起来不上那我这个，因为我上次看一个全部，就一个地址的，这个好像是那这两个，这个我没有看全还讲的，我没学鲁帮，考虑鲁帮，考虑偏平，啊，就考试时间，是。一般来说，喜欢语气。这后面好笑。那个也在说那些，就是说什么什么网投资文这一条啊，那天是之前是从那个，我这个队友就出来了，我其实就看你每一盒是就会，挺好的，会有很多浪费的。为什么要上课？就是我记得我小学的时候，初中的时候，有一个方式的想的，就是卖的好像香。这过程更像是技巧和这个还没结束呢，下节后用不到了，该先构上一对是的。完全是包括各种形式。在问题背景的时候，事后的观察会讨论到，最后给生活人，然后进行啊。啊，那素颜就冒出来一些东西当中，啊，就是你去了一次，你性格好，好是要然后受了啥了，你是还是很喜欢这个。这样，哦，对了，今天哦，确实不够数，还确实不够数，所以说，然后， 就在单纯上一个概率讲，然后后来我们把那个推到大，都推到好，再担心它以后会成为必须科学，那对吧？那
So hi, um, I'm glad that I covered the two welfare theorem. Although I didn't have time to do the proof, I mean, if you have time, I will just cover the big proof. I think it's the proof is very elegant. But let me finish the material first. If time, we go over the proof because the proof is not in the exam, so probably not in the assignment. Probably you're not that interested. But I want to show you a little bit about the proof to have some idea what's going on. So now, once we know the Lavoisier equilibrium has a very nice, the market has a nice feature, right? First is like, if we look at the market, at the end, you can't really further improve it in terms of efficiency, right? There's no way you can benefit anyone without harming others. Okay, first thing. The second thing is, even if you don't like the market, okay, you don't have to like the market because market need not give you the good result because it may not be fair, right? Because unfairness can be there, right? Because it can become from initially someone have a large endowment, right? Maybe there's a second generation of very rich people, right? And so on and so forth, right? So you can reallocate based on taxation, based on whatever method, you reallocate and still let the market works. And the market still works nicely. Okay? If you want any outcome that's efficient, market can achieve it by moving around your endowment. Okay? So that means that you don't have to need someone to actually dictate how to reallocate resources. You only need to dictate how endowment works. Okay? So that would be the idea. Okay? As long as you're able to figure that out, okay? Of course, how to figure that out is an issue of public economics, right? But that is something that beyond the scope of a class, right? And if you move around, actually, something will be destroyed, right? At the end, there will be trade-off between fairness on equity, right? That's always the trade-off with that. But either you want to get the cake bigger, but not everyone the same share, or you want to get a small cake, but everyone got similar share. So there's some trade-off between that. Okay, but that is not our concern at the moment. So next is, if we are not restrict ourselves to the price system, what can we get? Okay, just open your mind, right? Actually, you can imagine that's what happened when they think about during the Cold War period, right? They think about, okay, let's not restrict ourselves to the price system. Whatever system you can imagine, okay, let's see whatever system you imagine, what will you get? Okay, and we focus on one particular in our class, and you look at the Mass Code, which is the green textbook. There are many ways to do it, but we focus on one particular one, okay? And later we'll talk about this, basically about the idea of core. But what is core? You have to define core, we have to define two concepts. First is what we call individual rational, okay? I think there's a very minimum requirement, okay? The requirement is you can't force people to do things. Every people have property right, okay? You start with the thing that in any allocation is individual rational is if his utility is more than his original point, right? Basically, he can always go home. Okay, he can say, okay, no, I'm not going to do anything. I go home. Okay, that means lie down, right? 躺平 actually was what that, right? 躺平 constraint. Okay, I don't want to do anything. I just 躺平, right? Just right. I don't care what you do give me. I just lie down, right, and don't do anything, right? Okay. Now, second means 躺平 is like individual action. Okay, And blocking is not just individual, it's a group. Okay? And what it means is an allocation is blocked by a collision of I, means that there's some people, some subset of people, S is a subset, the end consumer, right? I consumer, some of them go away, okay? Some people go away, okay? And they go away with their resources, okay? For I and S, some of the resources, okay? Okay? And they pick their allocation, okay? Of course. They say, okay, no. Okay, you tell me this is X, okay? I tell you that no way. I propose another Y, okay? And I just use our own resources. I don't care about all the others, but you guys, whatever you do, what we do within ourselves, okay? As long as you guys are doing feasible thing, I don't care. What we do is, for all of us, we deal away from that, okay? Our payoff is Pareto improve, okay? Is just the same thing, okay? This group of people, as people, they break away, they propose a new thing, they only use their own resources, okay? Okay? And in this group, everyone is making better off, and some of them is struggling better off. Okay? It's like we have 20 people here, okay? Maybe I propose an allocation, okay? And 5 of you say, no, this is not good, okay? 5 will say, okay, let's about the other one, okay? And 5 of you use your own resources within themselves, right? 5 of you, your allocation is basically use up your own resources, is executable by yourself, okay? In that case, you guys pay off 5 of you are better than before, okay? Is that clear? So, is that clear? So, 5 of the 20 people, 5 of you propose another allocation for everyone. Of course, that must be feasible for the whole group within the endowment, okay? And must also be the new allocation, 5 of you propose, and 5 of you actually better off. And of course, within your resources, you just trade within yourself. You just reallocate within yourself. You don't care about the rest, but 5 of you do it, okay? Is that clear? Because you can imagine, right? All the rest outside the S, they just keep the endowment, right? It's feasible, right? So basically, imagine the simple is like 5 of you just go to an island and just live yourself, right? Become independent, right? Basically, go to another island and live by themselves. Okay? And in the rational, it's simply that one person blocking, right? He just go away by himself because go by himself, his endowment use up himself, right? The maximum we can do, right? Just say that's why IR is not blocked by any one agent, of course. And now here comes the definition of the core, which is the most important one. I mean, probably the easiest one in corporate game is the core is allocation that it can't be blocked by any group of customers. Okay? So I propose an allocation. None of you can form a group that can block it. Okay? Is that clear? Pareto efficient is the way that only focus on everyone. Okay? And core is Pareto efficient in every single subgroup. Okay? Any group is no way they can improve themselves. Is that clear? Because Pareto efficient focus on you can't improve everyone, right? Without worsening some people. But look at some only subset of people, not just everyone. Just pick up some people. Can they do better? Okay, this is stronger than Pareto efficient, right? Much stronger, right? Because not just for the whole group, but you pick up any small set of the society, can they do better by themselves, right? So we'll call this core if none of them can do it, right? We're very strong idea, right? It's a very strong idea. There's no price here, right? Remember, there's no price, nothing. Okay, So look at this allocation. Is this allocation immune to deviation, right? And this is very strong, okay? And how to achieve it is another issue, but we just focus on what are the outcome that we think is stable, is good, right? If the allocation is in the core, that's good, right? I mean, at least there's no one can do away with that. Of course, it's very strong. That means that not every situation core is non-empty, right? May not exist, okay? And luckily later you see in this exchange economy, there's always a core. And turn out there's a problem, the core is very large. But I will talk about that in the diagram, okay? So, the other way around means that the core means that there's no other allocation that will block the outcome. Just rewrite that. Okay. So indeed, if you recall the graph here, the one I draw, the orange, is the set of individual rational, right? And not a parameter efficient, right? But if you do parameter efficient, you would find a tangency, right? So you would be something like, probably like this guy. I don't know, if you draw the tendency, probably some line there, right? Then I should be a little bit more careful here, something like here, okay? And the blue one will be this Pareto efficient and individual rational. And turn out to be, if you have two agent, Pareto efficient is same as core, individual rational. So this blue thing will be the core, okay? And you can see there are more than one, right? There are many, right? But anyway, let's get back to the system. Okay? You can imagine that if you're more than one agent, there will be a lot of core. So first, I think it's very trivial. All core are individually rational, and all core per division. I mean, that's by definition, because we require that. But I guess this most important result is like this one. Is the velocity equilibrium is core. Okay? So that means that if you can imagine many complicated ways they can work together, and you think core is an important concept, no one can break away from this, then this is the thing, right? That means that if I have an economy that is allocate good by market, okay? There's no way that any group of people can get better by breaking away from the market. You can't better have a small market. You can't better by colluding some way. There's no way you can improve, okay? Any subgroup, okay? You have 20 people here, okay? No one can be better off by getting out of this room, by trading themselves. There's no way. The market already tell you this is the best already. Okay? There's no way you can improve unless someone wants to sacrifice, okay? If no one wants to sacrifice, you cannot improve. So that's why this very strong stability concept of the market. So market is very strong, right? In that case, right? Because no one can do away better, even if you use other method. Okay? You use a dictator, you use any randomized machine, use AI, even AI cannot do better. Right? Here you can see, right? Even your AI, you can't improve the market outcome. Even your super intelligence, there's no way. Okay? Unless you are someone who wants to sacrifice, right? But no one to sacrifice this outcome. So that's very strong, right? So that means that this is a very strong result. I don't want to do the proof. It's not something terribly difficult. It's a 3-line proof, but I just don't have time to figure that out. Okay. But of course, the more interesting thing is the reverse, right? Is what about other allocation, right? There's a lot of core, okay? Can we have market equilibrium that implement all the possible core? Okay? The answer is directly is no, okay? But qualification is if the market is larger and larger and larger and larger, the core will shrink to a single point that is complete equilibrium. That means that we have large economy, market itself is done deal. Okay? In a small economy, you can have something beside market that you can maybe work as well as a market. Okay? But if economy is good, it's big enough, you have billions of people, trillions of people, then there's no way you can have anything other than market. Market is the only way you can do things if you consider, say, stable outcome, right? Because you want stable, right? No one can break away from this, right? Then market is the only way. If you have a large economy, we have a big economy, if you don't want people to go away from this system, market is the only way. That is called the core convergence property of market. So let me state this formally because this is very technical about this, how you go to infinity. If you learn math, how you go to infinity matters, okay? But let me tell you how to go to infinity. Okay, this one. So here we define the term called type. Okay, the consumer are characterized by two things, right? Endowment and preference. Okay. Okay. Then how can you get to infinity? It's called replica economy. Okay, which means that we have a consumer, they have some preference, some endowment. Go to infinity means that I have another copy of me. I have DNA, I clone myself. He has the same endowment, same preference. Okay? Regardless of how you have economy, right? You have one me and another you and another me. I mean, no matter, doesn't really matter your preference or endowment. I just copy you and me 1 time, 2 times, 3 times. If you copy, that's called R replica. Everyone is copied by R times. I don't need to specify how it looks like, but you copy yourself 2 times. Okay? And you copy yourself infinite time. The core is very big, but we shrink to only one thing. It's the Laplacian equilibrium. Okay? So that is very strong, right? Because if you think about a market growing and growing and growing, okay, which is, I think it's replica is a right thing. I mean, because I don't think everyone is super different, but there's a good approximation, right? Everyone very similar, right? And at the end of the day, you can't do better than market. You can't beat the market, right? Of course, second welfare theorem will work, but if you think no one can do away with the endowment, right? You start with endowment, you start with that, that's done deal, okay? And to get the second welfare theorem, you can allocate endowment, then only market is the only thing you can consider. The only the government can do is reallocate endowment. And after that, you should leave the market to do it, okay? Because even if you can do better than market, you are having the same outcome. There's no way you can beat the market, okay? Not in terms of efficiency, in terms of no people want to break away from the system, right? If you want people to participate in the system, that's the only thing you can do, okay? So I hope that convince you that market is good. And that's why most of the economists are champion of free market, right? That's the idea. Of course, you ask, okay, if this market is so good, then why we study economics, right? We are done, right? Econ should stop here. End of the story, no more, right? And you know that we are going to go on for the rest. There are many things, right? First, we don't have production, okay? And again, if there's no market power and there's no monopoly, everything is fine, right? Because if you monopoly, no longer price sticking, right? So everything doesn't hold very well. But as long as the market works very well, then that's the thing, right? But the more important part is uncertainty, right? So far, everything is not very nice. Okay. What happened if uncertainty? And that is proof that if you can trade contingent good. What it means we talk about next class is you can have different state of the world. Maybe tomorrow is raining, tomorrow is sunny, right? And you can have different good is you have umbrella in the sunny time, umbrella in the rainy time, right? Then different state of the world, different good. If each good can be traded, okay? And there will still way to solve this. You have the financial market to trade the future uncertainty, and you will be equilibrium. As long as you can trade, okay, for every contingency, that's called the complete market assumption, that there's no problem with uncertainty, as long as you can trade, okay? But what happens if you do not, right? The problem is, it's okay, you can trade. But if you can't trade, right? Because how can you trade things in 10 years later? Can you trade? You can't trade, right? So, right, you can't really trade what happened 100 years later, right? You can't really trade. So what happened is there are some way to do it, right? Because not everything can be traded, okay? And the good thing is if agent and profit foresight, okay, you still have a Pareto efficient equilibrium. There's the render equilibrium. And then because of that many things to trade, okay, you have to reduce the number of contingent good, okay? That means that you need to have financial assets such as financial options, okay, can be defined. So that means that this actually gives rise to the idea why we're a financial market, okay? And I don't have time to go over all this because actually if you go this, there will be 4 chapters in Mascot Livingston Green textbook. Probably if you really do it, you cost us a whole semester to go this thing seriously. Even whole semester is not enough, I would say, because it's very mathematical complex, okay? But anyway, if you do finance, asset pricing, this is what you will learn, okay? At least in the chapter 1 or 2, or they will skip it, but anyway, this is the foundation for the thing. But why this is still a problem, okay? And then you ask why this general equilibrium is active in the 60 and 70, just die, okay? One thing is probably you know the Arclough paper, Lemon market. That one actually killed the general equilibrium approach because the single market, everything is very simple, and Lemon just killed the market, okay? For those who don't know, Lemon basically just a second-hand car, right? The seller knows the quality of the car, the buyer doesn't know, and because this is the case, then the buyer don't want to pay for the average price, right? Because if you don't know the quality, I only want to pay the average quality of the car, right? But that means that if you know your car is good quality, you don't want to sell, right? That means that good car will left the market, only left the bad car, okay? But if that is the case, then people will revise the belief the average quality would drop. And that means the market shrink and shrink to very small, then the market doesn't work out very well. And that actually happened in the marriage market, right? Because everyone say he's very good or she's very good, right? But we don't know. We can only pay for the price for the average, right? But it means that the very good will drop out the market, right? So that's actually what we see, right? Who is not getting married? Not the best woman or man, not the worst woman or man who don't get married. It's the best woman and man. Why? It's Lemon problem, right? If you know you're good, you don't want to be in the market, right? Because you're evaluated as average, right? So you get out, right? But if then the market only left is just like the lower quality men and women actually get married. But actually you don't look at the data, right? Who are not getting married are women and men with high earning ability, right? I mean, not the one who are poor, right? Turn out to be the actual Lemon market, right? So information asymmetry actually cannot have market equilibrium, right? Okay, so that is the reason why economists actually in the 70s and 80s turn to information problem, right? And people also look at other things called externality, transaction cost, property right, and also contract enforcement, right? I mean, in the world where there's a transaction cost, right? It's not the court is not free. Even the court is not perfect, right? There's something court can do, court something can't do, right? Only if you can present the data, evidence to the court, then that can be solved, right? If the evidence is not there, you cannot do it, right? There's a lot of contract theory talk about those kind of problems, right? Also externality, right? If A affect B, A affect B, then affect C, right? That's an ESG thing, right? That's these days people care about those, right? ESG is a big thing there. And also income information, income market as well, right? It's not everything can be traded, right? So there's a problem, right? And just like the marriage market again, right? And at least in most of places in the world, marriage is a lifetime contract, right? Of course, there's that place. I think there's some place in the world you can sign a marriage contract for 10 years or 5 years. That's a fixed contract. But in most of the places in the world, you can either get married or get divorced, right? There's no middle ground. That's incomplete, right? So you have to commit for a very long run, okay? So that is the idea. But if incomplete, that means that there will be something that, I mean, you only want to get married for 5 years, but you can't, right? So it end up to be inefficient because incomplete contract. You can't really buy it, right? Just like if you want to buy a computer, you either buy it or you don't buy it, right? You can't buy half the computer. You can't, right? That's a problem, okay? So that means it's inefficient, right? Just like many people want to have 2 kids or maybe 1 kid or they want 2 at the maximum, right? But maybe 2.5 is better, right? But you can't. You only have 1 more or no, right? Or some people would want to have no kid and maybe have one kid, right? But 1 kid is very troublesome, but they can't, right? So what happens is they have cat or dog, right? It's half kid, kind of, right? But that's the idea, okay? But the human, but you can't, right? So that's an issue there. Anyway, I guess I cover the everything there except some proof, but you don't need the proof anyway for your assignment. So the assignment will be released later today or this weekend on the topic 2 and 3. I think after the submission, then 1 week later, the tutorial. I think should give you 1 week or 2 then to do your assignment. But don't worry, it's just like computational thing. Just need to compute the firm optimization problem, compute all this thing. Okay, so I will see you next week. Have a nice holiday, Mid-Autumn Festival. Enjoy.